Imagine two particles, light years apart, instantly influencing each other's state. Impossible, right? Even Einstein called it spooky action at a distance. But what if this isn't just science fiction, but a profound reality that reshapes everything we thought we knew about our universe? Get ready to have your mind blown with quantum entanglement. Imagine two tiny particles born from the same cosmic event, separated by light years, yet somehow still dancing to the same invisible rhythm. No signal, no wire, no wave traveling between them. And yet, change one, and the other changes instantly. Einstein called it spooky action at a distance. To him, it defied logic, an unsettling crack in the foundation of physics. But this isn't science fiction. This is quantum entanglement, a real measurable phenomenon that challenges everything we thought we knew about how the universe works. And what it reveals could reshape not just the future of technology, but our entire understanding of reality itself. At the smallest scale we know, smaller than atoms, smaller than protons, the universe behaves in ways that seem to defy all logic. These two particles were once part of the same quantum system. Now, even if we separate them by miles, or even millions of miles, they remain entangled. Their states, their spin, their momentum, their energy are no longer independent. They are one system split across space. Change one, and the other reacts instantly, as if distance doesn't matter, as if space itself is just an illusion. Let's simplify this. Imagine flipping a coin here on Earth, and somehow a second coin on the moon always lands the same way, the exact moment you check. Not just once, but every single time. It's not communication, it's not a trick, it's a deep connection, written into the very fabric of the universe. And here's where things get strange. According to the rules of classical physics, this should be impossible. No force is traveling between these particles, no message is sent. Yet what one does, the other already knows. This isn't a theory waiting to be proven. It's been demonstrated time and time again in laboratories across the world. Entanglement is real, and it's shaking the pillars of physics. So what does it all mean? If particles can be connected across vast distances, what else might be connected in ways we haven't yet discovered? So, how do we know this isn't just some cosmic coincidence? Some strange trick of the math or a glitch in the measuring tools? Even Einstein didn't buy it at first. He believed something was missing, that these spooky results were just masking hidden variables we hadn't yet discovered. Local realism, the idea that objects are only affected by their immediate surroundings and have definite properties, even when you're not looking, was the cornerstone of classical physics. But quantum mechanics doesn't play by those rules. Enter John Bell, a physicist who, in the 1960s, devised a way to test if local realism could still be true. Bell's theorem laid the groundwork for some of the most mind-blowing experiments ever conducted. In these experiments, entangled particles are shot in opposite directions. They're measured simultaneously. And the results? They defy every classical prediction. Bell's inequality shattered. Hidden variables? No longer a satisfying explanation. These particles weren't just reacting, they were connected as one. Now here's the kicker. These changes happen instantly, was faster than the speed of light. Einstein said nothing could move faster than light. But entanglement doesn't send a signal. It bypasses the rules. It doesn't transmit information. It just is. It's like the universe has a hidden back end, a silent, invisible code linking distant points as if they're side by side. And we're just scratching the surface. Next, how entanglement is going from theory to technology. What was once just strange theory is now turning into world-changing technology. Right now, scientists are launching entangled particles into space. One of the boldest experiments came from China, the Mycius satellite. It successfully sent entangled photons from orbit to Earth, proving that entanglement works, not just in the lab, but across continents. This opens the door to quantum communication, messages that can't be hacked, intercepted, or forged. But it gets even wilder. Quantum computers use entangled qubits to perform calculations beyond the limits of classical machines. Where a normal bit can be 0 or 1, a qubit can be both at once. Link a few together through entanglement, and you get a system capable of astronomical complexity. We're not just talking about faster computers, we're talking about solving problems previously thought impossible. Simulating molecules, cracking encryption, optimizing systems on a global scale. But entangling tiny particles is just the beginning. What if we could entangle larger systems? Not just photons, but entire objects? This is the cutting edge. Researchers are attempting to entangle clouds of atoms, even mechanical oscillators, tiny machines. The goal? To understand whether entanglement can scale and whether it might one day apply to living systems. It's a bold idea, but if successful, it could rewrite our understanding of biology, consciousness, maybe even time itself. Entanglement is no longer just weird physics, it's becoming the backbone of tomorrow's technology. Next, we explore how it's already transforming our digital world, from unbreakable encryption to machines that could reshape reality. This isn't just for labs and blackboards. Entanglement is the engine behind real-world revolutions. Quantum cryptography could make our data absolutely secure. Quantum computing could model the entire universe on a chip. And ultra-sensitive sensors may soon detect diseases before symptoms even appear. But the weirdest part isn't what we can build. It's what this says about reality itself. If particles can affect each other instantly across space, is space even real? Is everything connected? Are we missing a deeper layer, a hidden quantum web tying the universe together? Entanglement forces us to ask, is the universe local or is distance just an illusion? We're only beginning to understand this quantum connection. But one thing is clear. It challenges everything we thought we knew about time, space, and reality. So, if particles can talk across the void, what else is out there, quietly whispering in the dark? If this blew your mind, you're not alone. Subscribe for more deep dives into the mysteries of the cosmos. And let us know in the comments, what do you think entanglement really means? Thanks for watching. You made it to the end, so give the video a like. If you want more like this, click the subscribe in the middle or check out one of our other episodes on the left or playlist on the right. But most importantly, keep looking up. Thanks for watching.